So now let's go ahead and take a look at the template method implementation in C++. And as you'll see here, we're going to define our ET event handler class, which inherits from another class called event handler. And event handlers used by our event dispatcher, which is called the reactor. We're not going to talk a lot about that. I mentioned it briefly in my video on singleton, and you can kind of take a look at how it works. But I'll talk about it enough here to make sense of how it all fits together. The reactor is going to call back to the handle input method, which is overriding the virtual method that's defined in the event handler class. And so that's the template method. These are the calls to the hook methods: prompt user, retrieve input, make command, execute command, and so on and so forth. Here's the factory method that I use for my example to implement the various subclasses of ET event handler. So you can see that what we do here is we have a factory method called make handler. We pass in a Boolean parameter called verbose. If verbose is true, we use the make unique method, which is itself a factory method that will make a unique pointer. It's a factory method for unique pointers. And we go ahead and allocate a new instance of verbose mode ET event handler. And we do this just to manage the memory cleanly. And if verbose mode is not set, of course, we're going to go ahead and make succinct mode instead of verbose mode. But in both cases, we're going to return a unique pointer for this. This is not the only way to use the factory method pattern. This is probably not even the best way to do it. It's a little tightly coupled to the subclasses I defined, but it was good enough for example purposes to make the program work and not get too carried away with abstracting in ways that weren't really necessary. Here's what the verbose mode ET event handler looks like. You can see it's got a bunch of methods like make command. And what make command does is just goes ahead and forwards to the make command method on the command factory, passing in the user input. So that's what it does for verbose mode. So this is basically a specialized hook method. And here's the same hook method for succinct mode, which, as you can see, just prepends the macro space keyword in front of the user input so that it'll make a macro command. It instructs the command factory to make a macro command as opposed to an eval command. And if you go back and watch the factory method pattern, I show how this all is implemented. So what we're going to do now is we're going to actually take a look at the source code for ET event handler, both the definition of the class as well as the definition of the methods that go in the class and the subclasses from it. You can see that ET event handler is an event handler. It has this make handler factory method. It's got a handle input method that overrides the one that's inherited from event handler. And then it's got all these hook methods: prompt user, get input, make command, and execute command. Under the hood, it has some data members. It keeps track of the tree context, where the expression tree resides, the actual in-memory expression tree resides. We have a command factory that knows how to make the appropriate user commands. And then we also keep track of the last valid command that was executed. We use that for various purposes. Here is the verbose mode event handler. You can see that it overrides prompt user and make command, and it also keeps track of whether we've prompted the user for input yet. Here's succinct mode. It implements or it inherits from ET event handler and also overrides prompt user and make command. But not surprisingly, it's going to do it in a slightly different way. Here's the implementation. You can see the make handler factory method, which goes ahead and uses the make unique pointer factory method that's part of STL, which came in C++14, I believe. It's a very useful factory method to make objects and ensure they're always going to be managed properly with a unique pointer, so they'll be freed up when they go out of scope. Here's the handle input method. This is the template method in this pattern. You can see we prompt the user, and you can also see that prompt user was one of the methods that was overridden by succinct mode, ET event handler, and verbose mode, ET event handler. We then go ahead and get the input, and if there's no input left, then we shut ourselves down and bail out. Otherwise, we use the input to make the command. Now, again, make command was also one of those methods that's overridden by a subclass. You can see make command is different in both of those cases, as we'll see in a moment. Once we've got our command, we go ahead and we attempt to execute the command. And if that fails, we bail out, we're done. Otherwise, we keep track of the last command, and then we print out the valid commands at this point now that we've got that command run. And if something goes wrong, if we had an invalid iterator, we get a bad traversal type, invalid state. It'll kind of give some useful diagnostics to the user, and then we'll print out the last valid command. That's why we store the last valid command, so we can say, hey, you did something wrong, but here's where you can pick up from to keep going. So this is a way of using exception handling to avoid totally bailing out, but retreating or returning to a known state and giving the user another chance to get it right. Here's the getInput method. You can see this is something that is defined in the superclass, the abstract base class. So it gets a line from standard input as a string, and then it returns true if we should keep going, and it returns false if we are at the end of file and therefore should shut down. Here's execute command. You can see all it does is it just says, hey, command, go ahead and run yourself. So that's a very simple template method, or hook method rather. And then you notice we don't define prompt user, we don't define make command. We leave those deferred to the subclasses. And if you take a look up here at the various hook methods, you can see prompt user is a pure virtual hook method, getInput is not pure virtual, make command is pure virtual, and execute command is non-pure virtual. So we give implementations for getInput and execute command, but we make the user provide the definition, or make the subclass provide the definition of prompting the user and making the command. So if you come down here, you can see that here's prompt user for verbose mode, and it gives you rather, if you haven't prompted the user yet, we tell them kind of the starting point for everything, and then record the fact that we prompted them, and we print out a little arrow saying, or a little greater than sign saying, here's where you need to give your input as a command, format, whatever. Here's what make command is for the verbose mode. We just forward the input, which is going to be an input expression, into the make command factory method, which will make the expr command. Here's what we do in succinct mode. You can see we don't do all this verbose gobbledygook. We just print out the greater than symbol, and that's a prompt for the user to enter in their input expression. And you can see down here, what we do is we make a macro command for the input. So here, kind of make it a little cleaner. We're just saying, I'm going to make a macro command. Go ahead and do these things. I decided to do this and have a new factory method called make macro command because it seemed a little cleaner than always having to pass in the string macro space. But you could also do that as well if you wanted to. Okay, so those are the key implementation artifacts for this particular pattern. I think you'll agree that it's nice because you get this reuse of structure. It's nice because you get a lot of code reuse. And the only places we have to do anything different is where we need controlled variability.